Wait, apparently this is tournament counts in Greitzer.
Yeah, no.
But I also wasn't sent to here.
Oh, what?
Yeah.
Crazy. They were out like last
2
weeks or. Oh, so 3.6, it's perspective triangles.
Wait, this
Oh. I'll get this. Perspective triangles, Desargues theorem.
Oh.
So this will be really good for projective geometry. I don't know, man, anyone you gonna do the architecture? Architecture. So the geometric theory of perspective was inaugurated by the architect Filippo Brunelleschi in 1377 and 1446, who designed the octagonal dome of the cathedral in Florence, and also the Pitti Palace. A deeper study of the same theory is undertaken by another architect. So he did the same thing but better. Gerard Desargues, 1591 to 1661, whose two-triangle theorem was later found to be just as important as Pappus's. What does that even mean? Okay, it can actually be deduced from Pappus's, but the details are complicated. And we can far more easily deduce it from Menalaus. You guys know that, right? Okay. If two specimens of a figure composed of points and lines can be put into correspondence in such a way that the pairs of corresponding points are joined by concurrent lines, we say that the two specimens are perspective from a point. Yeah, so we'll have an example of that. So if the correspondence is such that the pairs of corresponding lines meet at collinear points, we say that the two specimens are perspective from a line. Okay. In the spirit of projective geometry, Desargues' two-triangle theorem states that if two triangles are perspective from a point, they are perspective from a line. To avoid complications arising from the possible occurrence of parallel lines, let us be content to rephrase it as follows. 3.6. So I guess this is Desargues' theorem, even though... Wait, this is not Desargues' theorem. Whose theorem is this? Maybe this is Desargues' theorem. Okay, so if two triangles are perspective from a point, whatever that means.
It means the points meet at one point.
And if their pairs of corresponding sides meet, and if their pairs of corresponding sides meet, then the 3 points of intersection are collinear.
Yeah, you can see from the diagram.
Okay, well, so what is it saying? Is that the diagram?
Yeah. Like the corresponding points will meet at one point, then like the corresponding sides are collinear, so at the
Alright, so sometimes if you see it too quickly, you have to explain to everyone else so that they can catch up, including myself. Okay, so so we're drawing this 3.6, is it?
Yeah. 3.6. I think 3.6 is
Red pen.
It's so weird.
Did I draw it right?
Yeah, it's correct.
It's like, it's correct.
But
In the worst way possible. So this is the shaded one, right? The color doesn't have the benefit of
there is two shades. Yes.
yeah. Assuming he has the virus, yeah?
Yeah.
Okay, that's okay, so I'm not gonna label the points of the only, yeah? So if two triangles, I guess the red shaded things are the triangles, yeah?
Yeah.
Their perspective from a point. So what is perspective from a point?
It means that like one point. Like if you label, I just know you label actually because of
Okay. Okay, so this is triangle PQR, yeah?
Yeah. Yeah, it just means that P prime, P prime, and R prime are coded. Yeah.
Oh, okay.
Yeah,
Okay, so P prime O, yeah? They all meet at O. That makes so that's what it means with two triangles with perspective of point, right? Yeah.
And perspective.
So it's not just the corresponding two specimens of a figure composed of points and lines. I guess the other points are also corresponding and they meet at O. It's not just the three vertices, right?
Yeah.
Is that right?
Yeah.
Like every point between P and Q is also considered.
Oh yeah. Wait. Wouldn't that mean they have to be same
Because
because they definitely maybe. Okay.
yeah, I guess it's hard to say. Maybe let's for the sake of it, just say the vertices for now, yeah. Okay, so two triangles are perspective from a point, then they are perspective from a line. So a perspective from a line means two specimens perspective from a line. The pairs of corresponding lines meet at the linear point.
P R P prime R prime.
This, yeah,
Yeah.
and this meet at that point. This meet at this point, yeah. And then the other one.
P R
E R. Oh yeah. That's called E, right?
Yeah.
Yeah. Okay. So if you ever have this horizontal situation like this, then you have this vertical line like this. Yeah, that's what it's saying. Oh, they have another figure that could be interesting. So I showed the other one
I
too.
think this is except just with the points.
Yeah. Oh yeah, it's like kind of sideways. It's like upside down and sideways. Okay, so again we have a theorem of pure incidence. Yeah. Two of many ways a diagram can be drawn. Here, triangle PQR and P prime, Q prime, R prime are perspective from O. Yeah. And their pairs of corresponding sides meet at D, E, and F. Yep. Some instances of perspective triangles have already been examined in exercises 3.2 of 3.3. Oh, I think that's the one before Menalaus, right? So every two of the three triangles are perspective from a point. Okay, so let's try and prove this, yeah? So what are we actually trying to prove? Restate this theorem in terms of stuff. So we're trying to prove E, F, D are collinear, right? Any idea how we might do that? This guy's got a book in front of him. It seems to be a theme, huh? Term 1, Menalaus. Okay, so what triangle could we use for this? So we want E, F, and D to be collinear, right? So the Menalaus could say something like we want to prove E, E, right? T, T, F, F equals like 1 or minus 1, yeah? What triangle do you want to take? Oh, really? Um, so you can use PQR, that works, yeah? So the way the Menalaus is you have the triangle and you extend the sides to the points, yeah? Where's E?
Nothing else really.
So nothing really joins to E. Yeah.
We can't really use ours, so we just need
Okay.
what did they do?
So I think they ended up using PQR.
Wait, what did they do? D, R, Q.
Huh?
Oh, and then it's oh, wait.
So I think they use PQR, but the question is like if you're gonna use PQR, why didn't you use Q prime, Q prime, R prime?
Oh, and then
They should be the same, right?
yeah.
Okay, so shall we say PQR then, yeah? So how do we do it? What would the formula look like? So like,
Wait, how did they use
let me just follow. Pretend you don't have. Use the book when it's convenient. So ideally, okay, this is ideally what would happen, right? It's like, so, one of the greatest mathematicians I was talking to, like when you're reading it, right? It's like just try to figure it out, and if you really can't figure it out, you can look at the proof for a hint.
Yeah.
So like this guy probably never read a proof in his life. That's the impression I got.
Oh.
He was pretty good though. He was the most agile-minded old person I've ever met. He was old, but he was like he was so sharp.
Was he like 60?
Probably 80s.
What?
His name is Elliot. Famous guy. PQR, what?
Yes,
Okay, PQR, what do I make? PQ.
Wait, what?
No.
Oh, I was just, yeah, P, R.
So E, yeah. E is on PR, right?
Yeah. Yeah, P, R. Are they only to be
Are they the wrong way around? It doesn't even matter.
Yeah, I don't know.
So what is the next one? This one's what's D on, right? D is on QR, yeah?
Yeah.
So you don't want to put the R on the bottom.
Yeah, that's the
Yeah, that we avoided that one, didn't we?
Yeah.
Okay.
QP.
QP.
Yes.
So there's only one way we can do this, right? Okay, is it minus or plus?
Minus.
Minus. EP. It's a minus. DR. QB minus FQ. QX. Yeah, okay, minus. So that's what we have to show, okay? Okay, what kind of stuff can we use? Something should be obvious even if you can't figure it out exactly.
What is it?
Well, I mean, you have to use the conditions, right?
So,
like, even if they don't give you nice things, you try to do something with them. But the fact that they're collinear is the condition, right? So that's gonna come into it. Yeah, I don't even have to look at that to know that's gonna come into it. Right? It has to be the conditions implying the conclusion, right?
Yes.
Otherwise, the theorem would be whatever you used to imply the conclusion instead of these conditions, right? So OPP prime is collinear. What triangle can we use for that?
Yeah. Whoa.
Oh yeah.
Or I don't know what they
Well, so E, you're saying E, R prime. So that goes to P prime, yeah? Yeah? Is that the only one for OP prime? F, Q, P prime. Oh, so you have three choices, yeah? Well, then you should really use like something like.
No, because like P and P prime are already.
Oh, it's already.
Yeah. Oh wait.
Okay. There's one of those, so we have E R prime, yeah? Guess that has, okay, that's interesting.
What is the right spelling?
Whence?
Yeah. Like WHENCE.
I guess if you didn't know the difference between whence and hence, it probably wouldn't hurt you.
Ah, okay.
So it's strange that. So if you use E R prime R, right? Is that equivalent to? Oh, do you want to try it? We could try it. No? No, no.
Yeah, yeah. I think it's a one of the
Yeah?
Yeah. I mean,
ER?
yeah. And one of
So what does it say? So if you said ERR prime, yeah? So the ER prime, yeah? And then P, say? Is it PR? RO?
yeah.
Then O R prime, yeah?
Outline, outline, right?
P prime E?
Yes. Yes. Yeah, it's the one.
The EP, right?
Yeah. Wait. Oh, yeah.
What else is there? So what happens if you take another triangle? So Q, Q. What did you have before? F, Q, sorry, F, Q, Q, right? So is it exactly the same thing, but with R replaced by Q and E replaced by F? Huh?
Yeah.
So then that's F, P, P, Q, yeah. Q, so, yeah. So there's anything in common?
Yeah.
That's P is in common, yeah? And then what about between these two? Nothing. Interesting.
Yeah.
I wonder if doing this will work, huh? So I guess if we do it the same thing for all three, right? We should get overall 6 lots of 3 fractions, yeah? And I guess, see, the thing is, we only need 1 from each, because we need 6 overall, right? Yeah. But this is not what the book says, so this may be a risk in terms of time, but I think it might be a good investigation. Yeah? I'm writing it. You're just watching.
You have to write it every
If I'm willing to write it,
year.
you're willing to read it. Alright. Well, let me at least write. Yeah. So this is P prime, yeah? Let's try this, because I mean, if we just follow the book, we'll never really appreciate, maybe this just doesn't work and the book is right and it's quick, yeah? Or maybe this works as well, but the book is quick.
Yeah.
So this is natural. This is natural. Doesn't this feel natural though?
Yeah.
So you always want to know why like the natural thing doesn't work, right? Maybe you're just too stupid to see what the actual natural thing is, or is it like this is not actually natural? Or maybe it actually is natural. It works. And then
The book is dumb.
just calm down, bro.
The book is
Okay, OQ prime.
yes. R
Prime B, yeah.
and then
R prime B.
Oh yeah.
Wait, what was it?
Yeah. R
R prime B, yeah. And then what was the other one? F. B, yeah. I'm gonna use some stuff to set it.
This is not gonna fit.
Pessimism.
We'll make it fit.
Okay, so what was the point again? B and B prime. So R, so let's start with something. So R Q, yeah? That's the R Q.
It's writing in the same order, like P O Q prime. So you can do that.
Oh, what? How?
Like because that one's E R prime and that's F Q P prime, so that should be D R.
I don't really understand what you said. Look,
Yeah, there's a right. Like
I'll just follow your instructions.
Yeah.
What are you saying?
D.
P?
No.
Oh, the next one, yeah.
What's that? D R prime.
Oh,
yeah, that's what I said. Yes.
Yeah?
Yeah. And yeah, that one's F P P prime. Yeah.
Okay.
Yes.
Oh, so maybe we can do DR. What's the QD first, yeah?
Yeah.
Yeah?
P P
P, P. QR, yeah? That's what you saying?
Yeah. R O
R O.
O
What?
Yeah. O double R prime Q. Yes.
R prime Q prime?
Yes. Yes. Yes.
R prime Q prime. And then
yeah, D. Yeah. Next one.
It is, you felt like you had space before, but now it's like yep, F.
U. Yes, F Q Q P.
F Q Q P, yeah.
E P P O P O O F. Wait. Wait, no. Q here. What? P.
Oh, yeah, we already have P Q Q up there.
What? Yeah, we're doing.
Where are we?
Wait a second.
No,
Wait, no, it's. No, it is P O. Yeah, but O. P O O F. Oh, no, P O O prime. What's O prime? I mean, P O.
You're saying P O.
Yeah, O
P prime, yeah?
Yeah, the P prime sign. P prime. P prime, P prime. Yeah, P prime, P prime. P prime F. Yeah, it's the same pattern.
It's been the same pattern for the last month.
They still can't manage to do this.
Q.
Prime F.
No, they can't. We already have Q.
That's P prime, P prime, P. They're both Q. Yeah, P prime, Q prime. Yeah, the top one.
Yeah.
What? Yeah, that one's a Q prime, the top one. It's P prime, Q prime.
Yeah.
For the third one.
I've been up top now, yeah?
Yes. The difficult after.
Okay, so.
You just have to follow the pattern. Q prime, Q. No, it's F. No, you can just do the whole thing. It's like doing the missing things. Yeah.
What is it?
F R. No. I'm just reading the whole pattern.
Oh, okay. It's not waste time, yeah?
F R R. No, I go down. R. Wait a second. Oh no. Wait, it's not F R. It's not. Yeah. F R is so long. Oh yeah. Oh no.
This breakdown. Let's see if the comments are howling.
It's not A. Yes, it's not A. Oh, the ball's playing Brawl Stars.
Yeah, if he's not distracting us, he must only be distracting himself.
Yes. Except like 4 times as much.
Okay, so what are we doing?
It's not F R. I P.
So it's going to be the PP. Something.
I P. T. I B. Q.
Triangles. What are the triangles?
No, B Q Q prime. Yeah.
B Q Q prime.
So it's I B B Q. B Q Q prime and then wait, so yeah, and then it's B Q Q. D Q
Q prime, yeah. And what's the other one?
E Q Q
E.
Yeah. I think we use all 6 triangles. B R prime, F Q Q prime.
Q Q Q prime.
I'll read it. Yeah, we basically. Yeah, okay. Seems right. Wait, what? We use. Oh, no. Yeah, it's all 6. Yeah. Okay, B R. Yes. B R R Q.
Okay.
Q O O Q.
Q O.
Yes. O Q prime. And then Q prime R. R prime P. Yeah. So close.
Yeah, they are too
Oh.
close.
Oh, okay. Okay. E R. Yeah, keep up this.
E R
Oh, R P.
R P.
Ah, yes, R
P.
P.
Some R P. Yeah, okay. E R R P.
P O.
P O. P O.
Yes. O P prime.
O P prime. Yeah.
P prime. R prime. R prime E.
Yay.
We did it.
R prime what?
E.
E. Okay.
Now,
Oh
did
my
they
God.
cancel?
Let's see if they work.
Oh, I did they cancel?
Did it cancel at all?
No, some did. Half of them.
Alright, let's just try to figure out what it should be. We want EP at the top here, right?
Yeah, wait.
So we want that one at the top, yeah?
Yeah. I think we only need half of them. Wait, actually.
What else do we need?
We need DR at the top.
DR at the top, yeah?
Yeah. And we need FT at the top. Yay.
Where's FT?
Yeah.
Here?
Yeah.
So that's good already, yeah?
Yes.
What else?
We need RE at the bottom.
Do we have that?
We do not.
So that's at the top, yeah?
So
we have to make
oh no, we
one.
flip some. Yeah, we flip some. Yeah. Easy. That means they do cancel.
Oh, what? You're looking for the actually cancelling as written? No, that's...
Yeah.
that's
QD's on the bottom left.
Right, so what are we looking for?
QD.
QD?
Yeah.
This one, yeah?
Yeah.
That's in the wrong place, right?
Yeah. It's fine though.
Fine. Alright, where else?
Yeah.
PF?
Yeah, it's the FP. Yeah, FP.
Where?
Like straight. Yeah, FP.
Here, yeah?
Yeah.
It's flipped, yeah?
Yeah.
Now that you realize.
Well, that's fine.
Okay, there should be 6 things. There's only 6 things. That's everything, right?
Yeah.
We got that?
Now we just have to cancel.
So EP, QD. So let me check these things as well.
Yeah, they're all good.
E, ER, SQ,
Limited.
yeah?
Alright.
What, you already checked they cancelled?
Well, I checked like 3 and that basically means they were cancelled.
Oh, I see. I love that.
Uh,
Okay, so this cancels with this, yeah?
Yes.
Huh?
Yes. Yes.
No and yes, they mean actually like as different as things as they could possibly be.
No. Yeah. Q prime, R prime, cancel with that one.
What is Q prime R prime?
There.
Thank you.
Stop.
Oh, here it is.
Yeah.
So that's on the denominator, yeah?
Yeah.
Where is it on the numerator?
Top.
Top?
Middle. Yes.
Yeah.
We should do like a coordinate system for this. Like reading from the left, you have like 1, 2, 3, 4, 5, 6, and then going down is 1, 2, 3, 4, 5, 6.
No.
So then you can find any fraction. Yes.
IQ and QI cancel.
Nice. Q1 left 1, 6. You see other 1, 6.
Oh, and I bet you if you could, like, if you chose the primes, you could cancel some other way and you get the primes.
Yeah.
Could you choose which ones to be upside down?
Oh.
It's like, this is too tiring for you. Well, back then, if you could do this, this is like,
The geniuses. Yeah.
you wouldn't be acknowledged just because no one understands it. But like, but at the time, you would be like,
In a few hundred years, people would be like, whoa.
it's like, no, and then back then I'd be like, well, God knows, it's okay. It's okay that no one understands. God understands.
Yes.
Okay, so P prime, what are we doing? Come on. This one, yeah?
Yeah, 1, 2, and none. Oh, whatever. It doesn't really matter.
I'm the one with the pen.
Yeah, we
Yes.
should
Yes.
square the system. 1, 5 and 1, 1.
Huh?
Well, like you can label all the lines
Like you said.
with 1 to 6, you know.
Like
If you go like 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, this would be like 1, 1, 1, 2, 2, 1. 3, 1, 4, 1, 5, 1. Yeah, just to make it easy to find. You know?
Yeah.
Like if you put it on like
Oh, or you can just say that now. You've just defined it.
yeah.
So if you say that, I'll be like, oh, shit.
Yeah.
Okay.
Okay.
1, 2, and 1, 6.
Well, is 1 the rows or the columns?
One
One
is
row.
x-axis.
Wait.
Oh,
What's a column?
let's do like if you do 1, it's the first row, first column.
Yeah,
I mean
first
first
column.
first row.
Yeah.
Wait, what? Oh.
So 1 is this, 2 is this, 1 is this, 2 is this, 3, 4, 5, 6. Yeah.
Yes.
Oh, okay. This
So that's
2,
2,
1, and 6, 1.
2, 1, RQ. Yeah.
6,
6, 1.
6, 1. Ooh.
Yeah, that was on split. Yeah. And then 2, 2. And 4, 4, 4, 5, 4, 5, 4, 4.
4, 5. Yeah.
Yeah, that one.
Okay.
It's split.
Yes.
3, 2, and 5,
3,
3, what? Are you gone?
3, 2.
Wait, what?
It's RO. RO. Yeah.
Oh,
5, 2. Yeah. Okay.
I thought, okay.
It's actually not confusing at all.
Yeah.
This is the problem, yeah? It's something not confusing at all is being conflated with so confusing.
Okay.
Imagine like if you actually couldn't understand this, that would be confusing. It's like, what's Menalaus? Why is collinear? What the hell? Why is there negative lengths? That would be confusing.
Yes.
Okay, this is like we have to match things that are the same. That's easy, okay?
Yeah. 2, 3,
2, 3, R prime T, yeah?
and I don't even have other one.
Let's find R prime D.
R prime D. R prime D.
So sad.
Where is it? No way. There's no way, right?
What? There's no R prime D?
It's not there.
Is there a
Did we do
mistake?
something wrong?
Is there a mistake somewhere? Let me just.
Let's go to.
Oh no, please.
Oh, that's discouraging.
Yeah. There must be something wrong. Maybe.
Wait, is R prime D not right here?
No, that one's definitely right. That,
Hold on.
Yeah, our prime D should be for O, Q, Q prime, O, R, R,
O Q Q prime.
and O, R, R prime. So it should cancel.
yeah, that's the bottom line. Right?
Oh, is that D? Wait.
No, that's not D. D, Q, Q prime D. R prime Q. Should we just do the rest?
Oh, let's see what's left, okay?
Okay, 2, 4.
2, 4,
Okay, 4, 1.
4, 1. It's like the first time he didn't come up with the second thing as he said it. He came up with a problem.
Oh no.
So O Q.
1, 5. 1, 5, then 5, 5. 1, 5, 5, 5. Yes.
Oh, let me cancel this OP first. Sorry.
Yeah, that's what I meant.
Oh, oh, that was rude. Okay, OP prime, this OP prime. Yeah.
Well, that fraction is exactly the same. Well, wait, no, that's the same thing.
R prime E. R prime E.
Oh no. There's no alpha
R prime D. E prime E.
Oh, all of the bottom right ones.
What do we need here? What do we get? What's left?
Oh, the 2 are fractions. 4, 4, 2, 6,
4, 2,
2.
6, 2. Yeah.
What is it? The circle, yeah, it's only the bottom right one. And 4, 4, 6. No. 3, 6, 5,
3, 6,
5, 6.
5, 6.
And also 4, 4, 6, 4.
4, 4. PQ, yeah?
4, 4, 6. And then you're left with all the bottom right ones. Up I D, up I D, keep up God.
Okay, so we're right left with these ones, yeah?
Yeah. It's
No, but that's 6 of them. We could maybe find it one more collinear
Oh.
again. It's not that bad. I mean, we had, what is it, 6 times 6, 36, yeah?
Yeah, we can.
And all but like,
24.
it's all but like 6 things that we didn't care about cancelled. And we're like, this is a folio. Let's move on.
And P
Yeah?
Yeah.
Is that it? That's all, yeah?
Yeah.
Okay, so the things we're left with, let's write them in the right order, yeah? So it's this on the numerator, yeah? The denominator,
Yeah. It's P prime.
P prime, yeah? And this is in the numerator.
Yeah, that's fine.
P prime F, yeah?
Yeah. And then
This is on the denominator.
yes.
P prime.
Yeah.
So this is on P prime F is on the bottom.
P prime D.
P prime D is on the top, yeah?
Yeah. And P prime, I mean, R prime D is on the bottom. R prime D. And then R prime D.
Oh, maybe that's the problem. Maybe that gives you the other one.
Wait.
So what was it called?
R prime D.
R prime D?
Oh yeah, that does give you. Oh no. R prime D. Yeah, and R prime D.
This is R prime E, yeah?
Yeah, because that's the same one that you did on.
That's the other thing you're trying to prove, yeah?
Yeah.
So we know that they multiply to 1.
Yeah.
That doesn't mean that they're equal to 1.
Yeah, you have to figure out which one. No. Huh?
Oh, that's interesting.
Kavan's still here, right?
Yeah.
Hi, Kavan. This is like there's something we need to type out here. Then he's like, Kavan.
No, he said there's a 15-minute lag.
What? 15-minute lag? He said that. How is there 15 minutes being waited?
Ashfield.
Oh yes.
It's like it takes longer to lag than the train takes to. No.
Yes. Optify used to go to Ashfield. I'm lucky. Jeremy one. With the green one? No, Jeremy. Oh. Video.
Oh, so that's interesting because that gives the other ones, right?
Yes.
Yeah, because we kind of knew the other one had to be in there, right? And if they're not cancelling, that's kind of weird. Because our ones would have, yeah. That makes sense though.
Yeah.
And then you can't conclude.
Oh.
So can you conclude? Is there anything you could do? Like they're reciprocals of each other.
Wait, what? How come? come the second one is positive while the first one is negative?
Oh, is this positive one?
Yeah.
I don't think that matters too much because you switch the orders of stuff. Or maybe it matters a lot.
But I'm pretty sure everything else is positive, right?
Oh, is it?
Or maybe everything else is negative. Well, I'm pretty sure they're all the same, so.
I mean, they're all keeping track of it the same way, so the sign shouldn't matter too much. Yeah, do we know anything else about those ratios? Let's see, EP on RB. EP on RB. D, R, OQD. FQ on PF. F, Q. 2 numbers times together with 1. Like if you need they'll both bigger than 1, and they both have to equal 1. Basic numbers. Yeah, do you want to compare this with what they did?
Attempt to.
Well, at least we know what happens here, so we can remember if anything comes up, we can still fix it, yeah? So basically, we just cancelled everything except for the 2 things we're going to show as 1.
Yeah.
Yeah? And then we're stuck with the product of 2 things as 1. Okay.
It's said like an hour and that.
No, it wasn't close to it.
Was it not? It's like 8:30 though.
Huh?
Can't we just flip the board so we can...
No, there's stuff on the other side too. That can only be done several times.
We've literally done like once really.
Alright, let's see if there's any difference to their approach, okay? So we have the triads.
D
So the triangles OQR with DR prime Q prime. DR prime Q prime. So they're saying this is collinear.
Oh. Yeah.
DR prime Q prime on triangle OQR. O, Q, R. So D, R prime, Q prime. And triangle O, Q, R. And O, Q, R, yeah? So we need to write down 3. So triangle OQR, triangle ORP, ORP, oh, and then OPQ. Okay. Yeah? Yeah. Okay, what's it gonna be?
OQR.
So DR prime, Q prime.
Yeah.
So DR prime,
It's like OQ. OQ prime, Q prime, Q. OQ prime, Q prime, Q.
Q,
D, D, R.
QD, DR,
R, R prime,
R, R prime,
I know.
R prime O.
Yeah.
Okay.
O, O. O, R, P, O, O. It's O, R, P, it's like and E, P.
Oh, yeah, I'll tell you, yeah, EP prime, R prime, yeah.
Yeah. Ah, okay. Yes, good. Okay. O, P prime, P prime, P. Yeah. And then R, R prime, R prime, E, E. What?
E, R, R prime, R prime O.
Have we done something wrong?
Well, it would have to be P,
P, D.
it would have to be R.
P, D, E, R. Yeah.
P, E, E, R.
Oh, I have to touch wrong.
So this is E, P prime, R prime on triangle ORP.
E,
So this needs to be an R, did you say?
that's wrong.
Okay.
That's the
P, E, E, R.
Oh wait, no. It's fine. It's just slightly weird. I think it's better.
So P prime, P prime, P. Yeah. So that's I on PE, R prime or R prime. Yeah, it's upside down from the book, yeah. But yeah, it doesn't matter. Yeah, okay, so what's this one?
O, F,
O, F,
F, P.
F, B, yeah.
So, P, P. Wait, P, P prime. Yeah. P prime.
P prime what?
O. That's all. So P, Q. So it's like Q, Q, Q prime. Wait, I forgot that.
It's F, Q prime P prime.
Q prime. Q prime.
Was this Q?
Q prime. Yeah. Wait. That one. Oh, that's correct.
Is there something wrong here? So the last one, everything's right, I think, so far, except for the last one.
One of them flipped and the other two aren't. Right, two of them are flipped and the other one.
So what's the triangle here? The triangle here is OPQ, yeah? OPQ doesn't appear in the bottom.
Right.
So OPQ and it's FQ prime P prime.
Let's do it again.
Yeah, so OPQ, right? So OP goes to F.
Wait.
No, OP goes to F. OP goes to P prime.
Also, it should be OP
P prime.
P prime P.
P prime P, yeah?
Yeah. And then P.
And then P O. P O.
P F. P F. F T. Yeah, P F F T.
PFFQ.
Yeah, that's correct. The last one's correct.
OP prime, P prime, PF, QF. Yeah, that's right.
Yeah, you did it.
Okay, let's cancel some stuff, yeah?
Yeah.
So PE is on top, yeah?
Yes.
R is on the bottom. So we got that, yeah?
D R T T.
D R Q T.
D R is on the bottom. So some of them have to be flipped.
This is flipped, yeah? That's inverse, yeah?
F Q is the middle bus.
That's flipped as well.
Yes.
Yeah? Okay, is all the stuff cancelled?
Yes.
Yes.
Yes. Q prime Q prime Q.
This,
Q.
this,
Open one.
this.
Yeah, and then the left and right one.
Yep.
Yeah, because of
Yep.
Yay.
Alright.
Whoa,
We did it.
It's off.
Okay, so why did that work and the other one didn't? Somehow doing those three removed. Yeah, so maybe you can see. Okay, maybe you can try and guess what three triangles you would need to get the other one.
You use. I think you just use P prime O instead of P O. P prime O P prime. P prime O R prime.
Yeah, like I think this is kind of like I got to asymmetrize it, you know. So here it's like the triangles play the role of this, and the collinearity takes the other one. You know what I mean? If you swap it around, you should end up with that with the primes, and then the other triangles, the triangles will have the primes. Yeah. So like instead of OQI, you'd use yeah. Does that make sense?
Yeah.
And instead of getting dr prime q prime, you get drq, right? Yeah. Switch the roles, you get the other one. So it separated them somehow. It's kind of interesting. Okay. Desargues' theorem is easily seen to imply its converse. that if two triangles are perspective from a line, they are perspective from a point. So if two triangles are perspective from a line, so if this is collinear, right, then they all meet at O. Oh, actually, did you see that we verified that it implies it's wait, did we? No. Okay, so we got the expressions. Not quite. So how does it imply its converse? So if E, F, D are collinear, yeah, then they're concurrent at O.
Or if you can use the converse of
Does it work? So
like you make like other
okay, so let's just go backwards and see, yeah. So this is true, yeah. Then wait, do we know anything about those three things already? So D R prime Q prime, yeah.
yeah,
That's still the same. That's collinear, yeah. And that's coming from triangle OQR. OQR. Yeah. So what would you write instead of O then?
you can do like 3 points, and if they're the same. Can't be weird.
So remember the way we usually show converses in geometry, yeah?
What is the way?
So I guess we draw in this other stuff, yeah? So I guess the question is what's OP, yeah? We don't know OP means, yeah, for example, yeah?
Oh, yeah.
Is OP, where's OP in all this?
It's clear.
Oh, we didn't even get an OP. Did we get an OP? No, it's OP prime, I guess, as well, yeah? So we have OP prime, and we have PP prime. Yeah?
Oh, yeah. But you can just show that OPP prime collinear is
Yeah.
so you have these three, and then you do that one.
Oh, good. Okay, so how do we show OPP prime collinear?
You use triangle. E R prime R. Yes.
Huh?
E R prime R. E R prime 4.
ER prime.
Yeah, it's the same.
Yeah. How do you turn this into that?
Because like code like
But you're kind of saying like all 6, like out of all the 6 things, 5 of them are 1, so the 6th thing has to be 1.
Yeah.
Yeah, I can kind of get that. So it's strange. Okay, so it's the only thing. So if we have another point here, right? Something like we're looking for like a O prime, yeah. And that's where it meets this line, I guess. Then you have this. There's a few triangles that don't quite work. Readily seems to imply combo. It easily seems to imply combo. Easily seems. If 2 triangles are perspective from a line, and if 2 pairs of corresponding vertices are joined by intersecting lines, the triangles are perspective from a point. The point of intersection of these lines. If 2 triangles are perspective from a line, so that's this line, yeah? And if 2 pairs of vertices are joined by intersecting lines, so it's just avoiding the parallel problem, yeah? So if these lines are parallel, so these lines have to intersect. The triangles are perspective from the point of intersection of these lines. Then they all intersect at the same point. Literally seems to imply converse. So you're saying, yeah, so you have the OPP prime thing from before, right? Coming off possibly 2 different triangles. I guess that's the problem with those two, that other thing, because they have 2 different triangles, so their times together equals 1.
Yeah.
Is it one of the exercises? see. Oh, actually, there's some other stuff we can see before we completely get stuck there. Okay, so it says in declaring that triangle PQR and P prime Q prime R prime, yeah, are perspective from a line, we mean that there are three collinear points, E, F, and D, which are the intersections of QR and Q. Yeah. RP and R prime P prime. And PQ and yeah, sometimes you just wonder when they say things like that, what do they mean? As in the first figure, yeah? Defining O to be the intersection of PP prime R prime. Oh, it's probably going to prove it for us. So sometimes it says the proof before the theorem, sometimes it says the proof after the theorem. So we wish to prove that this point O is collinear with Q and Q prime. Oh. So when it says easily seen, it's like it's easy to see the proof on the other side. Okay, so since FPP prime and DRR prime are perspective from E. Oh, that's what it means. It's seen to imply it's converse. It's actually using the theorem. It's not using the proof. So it's like F PP prime. FPP prime, yeah? F PP prime, yeah? DRR prime. So their perspective, are they?
No, he finds out all the time.
Yeah. Oh, so now they're perspective from E. That's pretty cool. So what's the conclusion? We don't have to read it. What's collinear? So they're perspective from a point, right? So that means they have to be perspective from a line. Yeah. So the sides.
The line is Q, because PF with a Q, and P prime, P R prime with a Q. So that means P prime, R prime have to meet.
That's pretty cool, huh?
Yeah.
Yeah. So the fact that these two lines, PP prime and R prime, have to meet at a line. Yeah. On that line, and they have to meet each other. There's only one point they could be. Yeah. So it's whatever. That's cool, huh? Yeah. So that's So that's what it means can be seen from the theorem. Yeah. Yes. Finally. Okay, so we can apply the theorem to them and conclude that the points of intersections of pairs of corresponding sides, namely O, Q prime, Q. Yeah, well, we did with O, P prime, P, it doesn't matter. Are collinear. This is an instance of a purely projective proof. Purely projective proof. I guess. Does it mean that the converse was an instance of a purely projective proof? I don't understand exactly what it means by purely projective, but I guess because it does have some ratios of lengths. But maybe it's just expressing collinearity. Okay. Purely projective proof. Yes. Yeah, I mean, if you can understand that by the time you finish this Olympiad geometry, that'd be purely projective proof. It's alliterated. Ah, yes. Yeah. Ooh, someone hit a like.
Whoa, I didn't survive. It's AFK.
It's AFK. He never said anything.
Yeah, he just edited like a Quran. You would do Quran.
I asked him, understand?
Understood. In the end, yeah, he was like, I'm like 20 minutes behind.
And then there's overstand.
Oh, understand.
So that was 3.6. That's pretty cool, huh? So that means all of chapter 3 is finished.
Whoa.
So we have a record of chapter 3. So the gaps that we have actually recorded somewhere else. Yeah? So in principle, you could learn like a genius and learn it all in like a week. In principle.